This is video number 6 for the assembly programming and reverse engineering course, and in this video I will talk about the stack. And the stack is an area in memory. Each thread has its own stack. A thread can be considered a program inside the main program. A thread is able to process instructions alongside the main program. There are single and multi-threaded programs, and a single-threaded program has just one stack, and a multi-threaded program has several stacks. Each thread has its own stack, and all threads share the same memory regions as the main program. The stack is used for local variables, function parameters, and return addresses, and on a Windows system the stack has a size of around 1 megabyte. Here we can see the frame main, or the main function. Then we have the return address, parameters, and local variables, and here's the frame foo. So foo is just the name for any function. And there we also have a return address, parameters, and local variables. And in the next video, then I will talk about stack alignment and Windows API calls, and then we can also see how that works. But for now, I will just explain how the stack works in general. The push instruction is used to save data on the stack, and the pop instruction is used to remove data from the stack. Pushing values onto the stack lets the stack grow to lower addresses, and popping values of the stack lets the stack grow to higher addresses. Push will decrease the stack pointer by 8 bytes. That is for 64-bit systems. On a 32-bit system, it would be 4 bytes. Pop will increase the stack pointer by 8 bytes, and again, in a 32-bit program, it would be 4 bytes. Here's a graphic of a stack, and the RSP, so that is a stack pointer. The RSP points now to this block. So let's say this is any memory address. Okay, then the RCX registers holding the value 1. We execute the push RCX command, and that means remove the RSP, and the RSP now has grown to a lower address, and we have saved the value 1 on the stack. Then the next instruction, RBX, is holding the value 2, and then we execute push RBX, and again the RSP moves towards the lower addresses, and we save the value on the stack. The next one is RDX is equal 3, push RDX, and the RSP has moved again. Here we have the number 3 saved on the stack, and the last one is this, rex is equal 4, push RCX. We move the RSP again and save the value on the stack. And then we can go to the pop instruction. So RSP points to the value 4, and now we execute this command pop RCX, and that means that the value 4 gets removed from the stack and it goes into the RCX register. So RCX is then holding the value 4, and the RSP started to move towards the higher addresses. Now the RSP points to the value 3. We execute pop RBX and remove the value 3 from the stack. RBX gets the value 3, and the RSP moved again towards the higher addresses. Then RSP points to the value 2. We execute pop RDX. RDX gets the value 2, and we move the RSP again. Now RSP points to the value 1. We execute pop rex, and rex is holding the value 1. And the stack pointer has also moved again, and that is how the stack works. Now we will do all of that in code. Then use the script to assemble the program. This and use this -0 parameter to disable the code optimization and adjust the path to whatever your own path is. If you don't know how to install NASM or how to use it with a Microsoft SDK, then just watch the first video. Okay, this is a program, and I will I will assemble it now, and then I will use x64dbg to take a look at the binary file. And yeah, I will explain the sub-rsp command in the next video when I will talk about the stack alignment and the Windows API calls, but for now it just decreases the stack pointer by 28 hex, and 28 hex, that is 40 decimal. Okay, now click this button once, the step button. Then we are here, move RCX1. RCX is currently holding this value. Okay, click the button once, and now RCX gets the value 1. And then the next instruction, RBX, will get the value 2. RBX is now 2. And then RDX gets the value 3. RDX is 3, and the last one is move Rex 4. So Rex gets value 4. And what we can see here, this is a stack. And stack points currently to this address. And we can also see it here. So this is a address of the RSP. It was addressed to where the RSP is pointing to. And the first instruction here is push RCX. Now click the step button once, and then we can see that the value 1 will get pushed on the stack, and the stack pointer will then point to this address, so it will decrease the stack by 8 bytes. Okay, and here we can see it has decreased the stack, and now the value is 1, so the value 1 was pushed on the stack. And the next instruction is push RBX. RBX is holding the value 2, so here we will see the value 2, and I execute it, and we can see the value 2. Next one is push RDX. RDX is 3, and the last one is Rex, that is 4. Okay, so we can see 1, 2, 3, 4. Now we will execute this one, pop RCX. Currently RCX is holding the value 1, and if we execute pop RCX, then RCX will get the value 4. So RSP points currently to this address, and at this address we can see the value 4. Okay, now I will execute it, and RCX has got the value 4. The next one is pop RBX. The stack pointer points to the 3, so RBX will get the value 3. And now it's 3. The next one is pop RDX. So RDX will get the value 2. RDX is now 2, and the last one is pop Rex, and Rex will get the value 1. But instead of just registers, we can also push memory addresses, or like here, the values directly. So this will push the value 5 on the stack, and then 6, 7, 8, and again we can pop the value back to the registers. And yeah, that's it for this video.